All right, time for something a bit different. This time I'm sort of working on a game, like making a prototype of a game I've been thinking about for a while. The basic mechanic that I want to do is like you're able to get into forklifts and then drive those forklifts around and lift things up, like lift up boxes and things. And in doing that, you have to try to get out of the level or maybe collect something. I haven't quite figured that bit out yet. Um, but the very basics of the mechanic require that it has to be a 3D game. In my head, for like as long as I've been thinking about it, I guess I thought about it earlier this year. It was like a 3D game, kind of like Pipe Bush Paradise or Steven Sausage Roll. But then recently, I was like tinkering with PuzzleScript a bit. I've done that in the past, and I was thinking maybe I could make it in PuzzleScript. Um, like PuzzleScript doesn't let you make 3D games, but I could sort of simulate a 3D-ness. So to, I guess, demonstrate, um, here is my game running at the moment. I have implemented very little of the actual mechanic, but what I've implemented is the ability to like run into the background. If I press X, I run to the background, and then if I press X again, I run to the foreground, and I can walk around these objects, right? So in the background, I can push the block. If I run back, I can run around it, then push it from the other side. Um, I have added the ability to get into the forklift, for which you'll see that's not as smooth as the like running into the background thing. And also, like as soon as I move the forklift, it just falls apart. That's not ideal, but you know, you get the basic idea of the kind of two-plane pseudo 3D thing where I'm running between the foreground and the background and running around things. Now, that's fairly easy to do as a concept. However, to like sell the idea of it, I've implemented these like animations, as you can see. So as I run back and forth, I've animated it. And I've also added things like shadows and stuff to sell the idea that it's a 3D space. Um, just because I thought it would be kind of confusing to understand the mechanic if it wasn't sold properly. Um, so taking a step back, I guess, in PuzzleScript, you like this is how you do it. It's like a web-based editor, and you write. There's a bunch of sections to the file that you're writing, and like the main one is the rules section, which is where you define the actual mechanics of your game. And it's not a like imperative procedural language or anything like that. It's just a very declarative. These are the rules. Follow these rules. So, for example, like this is a fairly simple one. Here's a vertical only rule. If there's a player moving vertically, then we stop the player from moving. So that's the like the movement property of the player. And then the second thing, the second part of the rule, like the after, we've removed that. So that means the player is no longer moving. So you write things like that, and um, that's pretty cool. That's like it's a nice way to write out the rules for a kind of Sokoban like type game. However, so you also write out your objects in the game, like the actual like visual representation of the objects in this file, like in a text based format. So you can see the way that's done is you write the name of the object, you write the colors, like a list of colors in hexadecimal, um, and then you write the actual sprite itself, where dots represents like a transparent pixel, like completely transparent. There's no partial transparency or anything. And then the numbers represent a position in this palette up here. So the 0 represents the yellow, and the 1 represents the brown, etc. Now this is cool, and this is kind of handy for like building prototypes of games or whatever, or just building simple like I would imagine doing what have I played recently? What was it called? Enigmash. Like the number of objects in that game is not crazy big, I guess. So it's probably not too crazy to manage. The problem is when you have a game where when it becomes kind of combinatorially explosive. So like my character can face left and right. Forklifts will also be able to face left and right. They don't right now. And then in those two positions, there's like animations of me running backwards and forwards. Those animations are made up of a whole bunch of sprites, and like PuzzleScript doesn't support like doing animations as a like it's not there's not a feature of the engine that is doing animations. What I'm doing there is I'm changing one object into another object into another object and so on until the animation finishes. So to demonstrate that, what I can do is I can change this. This again interval was set to 0.06, which means 0.06 seconds between each. Basically, in your rules, you can say when this rule has evaluated, run the rules again. That's how I'm effectively simulating animations here. But if I slow this down and then run it, you'll be able to see that if I like run into the background, you can see all the frames of my animation. So that's just me swapping one object for another object until the animation finishes. So then I can walk around again. Even when I turn around, I've got a little animation there. It's kind of funky. It looks odd at this speed, but it's basically like a motion blur on the character as they turn around. You'll see at full speed, it looks pretty good. Let me do that again. Into the background. Way, isn't that fun? Oop. So, yeah. So managing all of these objects gets kind of complicated when there's so many of them and you've got animations between them and look how crazy this is. And like if I ever change the color in one of them, changing it in the others becomes a real pain. And then not only that, but I also have these shadows that cover objects. And so, you know, if PuzzleScript supported transparency, like partial transparency, this would be fine. I'd just have a partially transparent shadow, but like shadow object, which I lay over the crate, but it doesn't support that. So instead what this actually is there's the normal crate object behind, and then there's another object laid over the top, which has the colors of the crate, but darkened. And then I have that on this side as well. So you can see how, like, I mean, so I've got those shadows on the forklift as well. Like, the more objects I add into the background, the more shadows I have to create, and it's going to get extremely complicated. So, to avoid this being such a pain, I have built a little script to help me. So the ideal situation is that I only have to draw each sprite once, and all the variations of that sprite are generated from all the variations of that. Yeah, so like all the objects that are variations of that sprite are generated from that single sprite. So what I've done is I've made a thing that lets me begin with a standard sprite map. So I can just draw this in GIMP or in Photoshop or whatever, yeah, pixel art program you want to use. And so that's like already easier because I don't have to deal with like writing out hex numbers and then indexing those colors. And if you shift a color around in the palette, then you have to change all the numbers and it's such a pain. Instead, I can just draw them, right? So each thing in here is a 5x5 sprite. And notice that I haven't drawn, so I've only drawn the right-facing character in the foreground. I haven't drawn the left-facing character. And that's because the thing I've built lets me automatically generate variations of a sprite from what I've drawn. So given this, which has got all my objects in it, in their like, in a neutral position, think of them as like the T-pose of the, if that's a familiar term to you, of the T-pose of each object. And then with that, plus, let me find the file, objects.yaml. So I have a YAML file as well. And so these are the two inputs. There's that sprite map image, which I've drawn in Photoshop. And then there's this YAML file that describes the objects that I want. And you'll notice what I support is, so this is not part of PuzzleScript, this is the thing I've built. I can name an object. I can tell it what position in the sprite map to grab that object from. So in this case, it's 0, 0, which represents the top left corner. So that's this sprite. So, wrong place. So character foreground is the sprite from that position. And I've said flip true, which means this is actually going to generate two objects. It's going to generate one that's facing to the right, one that's facing to the left. Makes sense, right? So, and then the same is true for the background character, which is at a different position in the file. Another thing I support is this sequence property. So this is set to 5. for this one. So this is for the animation. So this is saying take the position x1, y0, which will be this one, and then make a sequence of, I keep jumping to the wrong place, sorry, make a sequence of 5 sprites. And what that does is it says, there's like an assumption that that means there are 5 sprites in a row in this file. So that's all of these that form a sequence. And what it's going to do is generate objects that are numbered. I keep jumping to the wrong place again. It's going to generate objects that are numbered according to that sequence. So I don't have to list out each part of the animation separately. I can just say, here's the starting point, and it's a sequence of 5, and it will generate each object. But notice that I can also say flip true. So that's going to do a right-facing version and a left-facing version of all 5 of those things. So that means I end up with so there's 5 by default, and I'm flipping them, so 10 variations of that animation, and then 10 variations of the other animation, which is coming from the background to the foreground. So that's 2 things I can do, flipping and sequencing. But I can also do blending. So I mentioned the problem with the shadows is that I can't do partial transparency. Well, if you look inside my sprite map that I've drawn, I do have some partial transparency. Like PNG files support transparency, and so I have this sprite down here, which is the shadow. It's the shadow on the right. Like if there were an object there, this shadow would be cast on the right-hand side of the object. And these pixels are partially transparent. Okay. Problem is, I can't draw that. There's no way of representing that in PuzzleScript because you can't have partially transparent pixels. So what I do is I support this blend feature. Let me take crate, for example. So crate is at position 2, 3. Let's take a look. So that would be x is 2, 0, 1, 2. And then y is 3, 0, 1, 2, 3. So that's the crate, right? So that's the base sprite. Where am I going? Here. And what I'm saying is I'm going to blend that with a whole bunch of other objects that I've defined in this file. So these names represent other objects in this file. I consider these object IDs or something like that. I think I call them object IDs. So null says, first, just generate me one that is blended with nothing, because I want a base crate that I can just use without a shadow casted onto it. But then also blend it with shadow, and blend it with shadow C, and blend it with shadow anim. And what this actually does is it does an alpha blending of the sprite represented by this. So let's take shadow, for example. It grabs that sprite, and it does an alpha blending of that sprite with the crate sprite. And so there was a problem here. So if we go back to the PuzzleScript thing, imagine you had a sprite that had, I do have some sprites that have quite a lot of colors. Imagine you had one that had, here we go, look at this. I had 10 colors. The problem then is you can't actually do that in PuzzleScript because you can't write the number 10 into the grid. Like this, the most you can do is like 0 to 9. You can't write 10 to this pixel grid. So you can't have more than 10 colors. And what I was finding is because I have some quite complex background sprites and I'm casting shadows over them, that ended up giving me blend sprites that had more than 10 colors. And so to work around that, what this blend actually does is it blends the sprite onto the source sprite, like the base sprite, and then, but it only includes the blended pixels, the ones that actually got affected. The rest of the pixels get cut out. So what this means is in fact, let me find the example. So let's find crate in here. So the crate blended with shadow right ends up only being this shape, even though the crate is like a full square. The blended, the one with the shadow cast on it, is only got the pixels where the shadow is. So that means if I want to draw that shadow, what I need to do is draw that blended sprite over the non-blended sprite. If I just drew the blended sprite, I wouldn't have the whole crate. I'd only have the shadowy part of it. And so I've done this because it means I avoid hitting 10 colors quickly. It just means I have to draw 2 objects over each other instead of just one, and that's fine. So, of course, like, it's not just that simple though, because so I'm saying here blend with shadow, but shadow itself says flip true. So that means shadow generates 2 variations, the right hand shadow and the left hand shadow. And then I'm blending with both of those variations of that shadow. Right? I'm also blending with shadow C and shadow anim, which itself contains sequence. So this ends up generating 4 objects because I'm flipping them and it's a sequence of 2. And then I'm blending with that. So I end up with a whole bunch of variations of crate, right? Because I'm blending a whole bunch of things with it. So, so that's basically how it works. I write this file and I draw my my image, and then I run my script, which is written in JavaScript. So, well, it's like no JavaScript, not web-based stuff. And I just do this, and it spits out my objects, which I can select and paste into my my PuzzleScript. And you can see there's a lot. So this is really handy. So I'm only having to draw a few sprites and ending up with a lot more. I should probably count how many there are, but I can't bother right now. But yeah, I can copy that, take to my game that I'm making. In fact, let me paste it into this one I've got open over here. And like paste it in, and you see I've got all these objects. Awesome. So that saves me a bunch of pain. So that's basically how it works. It's kind of fun to write. It was an interesting algorithmic challenge. And so there are some like variations of PuzzleScript that let you do like transparency, like pixels with transparency and things like that. But I wanted something that I could run in the like main, like the actual version, like the main version of PuzzleScript, not people's forks of it. So yeah, I'm doing everything as a pre-processing step. There's another complication I'm going to have, which is to do with the rules. Like, you can see there's a lot of repeated rules as well, and I feel like I could quite easily come up with a way of writing these using some kind of pattern matching like expressions that would evaluate to a set of rules, which you can actually kind of do in PuzzleScript like by default, because you can make groups of objects like background includes crate or forklift or character background, in which case, like, if you reference background in a rule, it represents all of those objects instead of just one. So that can help you avoid writing rules, but I think I need to kind of figure it out, but I might need to have some kind of way of generating rules, like, that I can just paste into the editor. Should I talk about the code a bit? I could talk about the code a little bit, I guess, because it was kind of fun to write. So, where is it? It's in here. So everything starts in this file. So it's written in JavaScript, as I mentioned before, but it's like ECMAScript 6 or above. I don't know where it is, like 2018 or something like that. So it's all the new fancy JavaScript stuff that you couldn't do in web browsers until quite recently. And a lot of web browsers still don't support a lot of the stuff. But I actually quite enjoy writing JavaScript for Node. Like, I feel like people have some prejudice against JavaScript based on what they've done in the browser, like using jQuery and stuff, and it's all horrible. But you can write some pretty neat code with Node. So this is where everything begins. I'm just going to give a quick overview, I guess. So this is the main function, print objects, and what it does is it first reads in the sprite map PNG and processes it. This image class is something I've made. It's another file, but it has a from PNG static method which I can call. So this outputs a buffer. I pass that buffer to from PNG, and it creates an image, and that image contains a width, a height, and the actual data buffer, like the buffer of pixel values. Whereas, So that outputs a buffer of like the file contents, which includes like PNG headers, whatever. Whereas this image class ends up containing a buffer of just the pixel values, so like RGBA for each pixel. So then I take that, which is like the whole sprite map, and I call this other function I've written called unpack sprite map, which takes that sprite map and I tell it what the sprite width and sprite height should be, so 5 pixels each. I don't know why I made it generic, but I did, even though it's always going to be 5 by 5 for a PuzzleScript game. And that basically takes that sprite map and splits it up into a 5 by 5 sprites. So I end up with a 2D array here of images where each image is an individual sprite from the sprite map. Next, I read my objects.yaml file and use some library to do my parsing. So I parse the YAML, which basically just gives me the contents of that YAML file in my code. Then I loop over I loop over each object ID in that file. So I'm looping over character foreground, character background, etc., going through this list. And for each one, I get the object variants. So because each object ID produces a set of objects, I call this function called getObjectVariants, which gives me the set of variants for that object ID. And this is the function where all the magic happens. Like the actual logic of this script is all in there, really, which I'll go into in a second. I then loop over each variant for the current object and create a PuzzleScript object. So this represents, so like at this point, the variant is still a buffer of pixel colors like RGBA, etc., like a linear buffer. So this, once I construct this object, that's when I end up with my image being converted into a palette and indexes into that palette. So kind of like the structure it needs to be in here, right? So I end up with an array full of colors, and then a 2D array of pixels that reference that array of colors. Back to the code. So I create one of those. I then check, so there's another property I can set in my objects.yaml, which is emit true, which basically just says, even if this, okay, so I didn't mention that. So I guess I can mention it in a second. So if this is here, we're going to skip this. We're not going to write it out of the file. And that's useful for some of the, so I need to reference a sprite in the sprite map that I'm going to use for blending purposes, but I don't want to actually have an object that represents that. I'm not going to use it by itself. So emit true helps me do that. So if emit is true, then we'll skip it. That's what continue does here. It continues to the next iteration of the loop. Or if the object is blank. And so the reason that happens is because at this point, when I convert the linear RGBA values into like a palette indexing image, if any of the pixels are transparent or even partially transparent, I get rid of them. They're gone completely. So that can mean you end up with an object that is completely empty. It's like blank. Like take, for example, the shadow object. Like by itself, not blended into anything, at this point, I'd end up discarding all of the pixels because they were all partially transparent or completely transparent. And I end up with a completely blank object. So if it's blank, I skip it. Then I call this format function, which basically just turns the internal representation of the object into this format, like a name and then a list of hex like colors and then the actual numbers and the dots and so on. Okay, so then the actual magic is in getObjectVariants. I guess to describe this, I might skip down a little bit. Or I guess I can describe it conceptually first. So like, if an object has a set of like things I want to apply to it, what do I actually mean by that? What I mean is I want to apply every combination of those things. So so for flip and sequence, right? I want to have an unflipped 0, 1, 2, 3, 4. And I also want a flipped 0, 1, 2, 3, 4. So I want to combine every combination of them. And then if I've got flip and sequence and blend, which I could have, but I don't think I've actually done that anywhere. No, I haven't done that anywhere. But if I did want that, I would want it to do every combination of those, right? So effectively, like what you can think of that as being, that's not a sentence, but whatever, is I've got like a set of things I want to do. So let's take flipping, for example. There's the first variation of flip, and then the second variation of flip. There's the keep it right facing, and then there's the left facing variation, right? They're all the variations of flip. Then of the sequence, there's the initial sprite in the sequence, there's the next sprite in the sequence, and then depends on how long your sequence is, but up to Sn, I guess, right? And then separately, there is for blending, there's the first blend I do, and the second blend I do, and so on. Right? Depends how many objects you blended with. Bm. So then what I want to do is I want to, for every combination of these, so for F0, S0, and B0, I want a variant of the object. For F0, S0, and B1, I want a variant of the object, right? So what I do is, and then once all the F0, S0s are done, it ends up being F0, S1, B0, F0, S1, B1, F0, S1, B2, etc. Until we get to F1 and then S0, and so on, until we've done every single combination. So the way I do that is, well, first I call this get variant modifier sets, which is basically this object here basically contains this structure. I mean, it literally contains this structure. It's an array of arrays of things I want to apply to my object to create the variance. And then after that, I do this Cartesian product function on that on this array. So Cartesian product is like a standard maths function. I've implemented it myself in here. It's down here somewhere. Where is it? Here it is. I implemented it myself because a lot of the ones I can find in packages are like recursion based, and I kind of dislike using recursion unless I have to. So I implemented mine with a queue. But whatever, I won't go into the details of that. But what the Cartesian product does is basically generates every combination of these. So I end up with an array of F0, S0, B0, and then another array of F0, S0, B1, and so on. Right? All those combinations, I end up generating them. You can think of it kind of as being like, imagine this were a 3D graph, and these were the values along each axis. So F0, F1 along one axis, and S0, S1. So then the Cartesian product gives you every point in that space, in that 3D space. If that's a 3D graph with those values on the axis, if you imagine every point in that 3D graph, that's what I'm generating here. Whatever, that's just another way of thinking about it. So this function, get variant modifier sets, returns this, and you can see how it does that. Although, okay, before I get to that, so given that in fact, let me put that back in. Given that we've now got this, each of these sets of like modifiers gives me a variant of my object, right? So what I need to do is loop through all of these, applying the modifications, and that gives me my object that I want to actually write out into the file. Okay, that's what I'm doing. So that's what I'm doing with map. I'm mapping each of these arrays. So inside the map, I've got one of these arrays, like this. So what I do is I start off with a variant options object, which is just defaulted to the normal situation. Like if there's no modifications that have been made, this is the normal situation. So there's a source position, where the X and Y are just the X and Y from the actual object definition from the file, from the YAML file, right? And the suffixes is empty, and the flip horizontal is false because we don't want to flip, and the blend sprite is null because we don't want to blend anything. This is just the base situation. If I wasn't applying any modifiers, this is what would happen. And then for each of these variant modifiers, I apply it. So actually, so what these are in this array, so this array is this here, variant modifiers. So I'm looping over each of them, and each of them is a function that I call on my variant options, which transforms the variant options in some way. Okay? So by the end of this line, I've looped over F0, S0, and B0, and they've modified this, the content of this. And given that modified variant options, I can then build the actual sprite that I want to generate, which I do by extracting the source position, like as in by extracting this position out of the sprites 2D array. I then flip the sprite depending on what flip settings are in here, and then blend with whatever blend sprite is in here. And then I return, so I return a name, so I return that sprite, but also a name, and that name is generated from the current ID of the object that I'm blending. So that's like the top level ID, like crate or whatever, with all the suffixes. So this ends up being, I don't know if you know the syntax in JavaScript, but this would be like crate, and then this would be an array of suffixes. I should have put an extra, and then I ended that quote. So it might be something like this, shadow L, this will get generated, and then the ... expands that out into the containing array. And then I end up joining these with an underscore. So I end up finally with a final name, which is just each of the suffixes added onto the base ID with underscores between them. Okay. Undo, undo, undo. Okay. So you can see how that generates each of my variants. But then what actually are these variant modifiers, these like F0, S0, and B0? Well, let's go into this get variant modifier sets to find out. So remember, this is the function that generates it in this format, where it's like they haven't been combined yet. So let's go there. So what it does is it looks at the object definition that we're currently working on, and it checks, is the flip property set? Have we said flip true? If we have, then we add to our variant modifier sets two things. So these will be basically F0. Let's bring this down. So here I'm adding two things to the array. So well, I'm adding an array with two functions in it, which is this array here. And here's the two functions. Here's one function. Here's another function, which takes the variant options and modifies them. So in this case, the first one adds to the suffixes the letter R, and it sets horizontal to false, which is the default, but I'm setting it here just to make sure that, you know, if I change the defaults or whatever, I want to make sure this always works. So the second one I add is I add L to the suffixes instead, and then set flip horizontal to true. So these two things are F0 and F1, basically. Then I do the same for sequence. So depending on the number that I've set in sequence, I generate a function for each one, which takes variant options. It increases the X position, like where to grab the sprite from by current index in the sequence, and then pushes that index number as a suffix as well. So that's S0, S1 to Sn, all generated by this. Then finally, I've got the blend ones. And so the blend property, basically I have to loop over all the objects that are listed in the blend. And then I have to get their variants. So this is where this gets kind of recursive, because like I said before, crate is blended with shadow, but shadow has flipped true. So so at this point, blend ID is shadow. Like blend ID is shadow here. And so but I need to go and get all the variants of shadow to blend with all of those variants, right? So I basically recursively call the get object variants function. I loop over those variants, and for each variant of the blend object, I push in a modifier function, which takes variant options and modifies it. It adds the blend variance sprite as the blend sprite, and it pushes a suffix, which is the blend variance name, which is how I end up with like create shadow R, create shadow L, because shadow R and shadow L were themselves variants of shadow. Whatever, maybe that's complicated, but yeah, so this ends up producing B0, B1, B2 to BM. And as I said before, that ends up going up to here. We do the Cartesian product on it to get every combination of those, and we run every combination on the variant modifiers to produce the sprite that we want. Ta-da! And that is basically it. So in theory, it'd be quite easy to add other modifiers as well, or more complex modifiers. What else is in here? So I sort of skipped out what's going on inside image. I guess I don't really need to go over that, but so, I mean, we can briefly look at it. But as I said, image stores a width. It's a class, it stores width, height, and data, which is a linear buffer of pixel values. So it's 4 bytes per pixel times the width and the height. That's how many bytes there are in the buffer. And there's a bunch of like convenience functions in here. This is where the actual logic of like flipping and blending occurs. So this is a function that basically produces a new image, but where the contents of that image are the flipped contents of this one. This is basically just kind of funky maths to make sure I'm indexing the right byte in the buffer and copying the right bytes, etc. But yeah, I'm just like looping over every pixel and copying it across, but to a different position in the new image because it's flipped. And the same with blend. This is like a basic alpha blend type thing. Yeah. Just a standard alpha blend. I just loop over every pixel and blend them with blend the source image with this to produce the blended image, which I return. Oh, and the unpack sprite map function is also in here. This is the one that takes the whole sprite map as one image and splits it up into sprites. Again, just funky maths. I was actually really happy when I wrote this because, like, I wrote this entire thing like without running it, and then I ran it and it worked the first time, which never happens. It was pretty good. Okay, so that's that. The only other file is the one that defines PuzzleScript object, which is in here. Like I said, this is where the image ends up getting split up into, like the sprite image ends up getting split up into like a 2D array of pixels and a palette of colors. So that's what this is doing. And this is where it ends up discarding. So I loop through every pixel. I read out that pixel as a value. So this is me extracting the alpha byte of the pixel. If the alpha byte is less than 255, which is fully opaque, i.e. if the alpha is in any way transparent, this is where I like get rid of it. I push null into the pixels. So the null here represents the dot in the final object in PuzzleScript. I then add that color value to the palette and so on, and then add the index of the color in the palette to the 2D array of pixels. And yeah, there's just some functions in here for like checking if it's blank and for formatting it into the text that it needs to be in that I can paste into the PuzzleScript file. So yeah, that's that. Anyway, that was fun. Don't know if that made any sense to anybody or if it was at all interesting to anybody, but maybe I'll start doing these videos occasionally. I don't know. Like, I tend to have a couple of side projects on the go at a time, and sometimes there's interesting stuff to talk about, like this. So I might do it occasionally. I guess this is kind of a development log, but it's not like I'm really like working on a proper game. Like, I don't know. Maybe there'll be something interesting that comes out of this, but who knows? This is just, I'm prototyping. So this isn't the development log for a particular thing or a particular project. It's just in general what I'm working on at the moment as a side project when I'm not at work. Yeah, that's basically it. Let me know if you thought this was interesting or not. Maybe I'll do some more in the future. I guess one last thing is I should probably put this code on GitHub or something. I don't know. I haven't done that yet, but maybe I will at some point. Yeah, cool. Thanks. Bye.